Hi up, today's video is on satellites. Okay, so we're going to start by looking at the relationship between period and radius. Okay, so when a satellite orbits, the centripetal force acting on that satellite is provided by the gravitational force from the planet that it's orbiting. So we take the equation for centripetal force, mv squared on r, and we equate it to the equation for gravitational force, Newton's law of gravitation, gm F equals gmm on r squared. We can then cancel down the m's and the r's so that we're left with v squared is equal to gm on r. And then we're going to want to substitute in for v. So velocity is displacement divided by time. The displacement, if you're moving in a circle, is 2 pi r. And the time taken is the period of oscillation. Okay, so if we substitute all that into the v squared, we get 4 pi squared r squared over t squared is equal to gm on r. We can then rearrange that a little bit to get 4 pi squared r cubed is equal to gmt squared. Now, we can make the assumption that the mass of the thing that's being orbited is a constant. Pi is obviously a constant, 4 is a constant, and g is the gravitational constant. So that leaves us with the relationship t cubed is directly proportional, r cubed is directly proportional to t squared, which is Keplers law. I can't remember which of Kepler's laws, but it's one of Kepler's laws. Okay, anything that's orbiting has kinetic and gravitational potential energies. And if we move an orbiting object between the different types of orbit, as the GPE increases, the kinetic energy decreases and vice versa. So if we take a look at what that means in terms of moving from a high to a low orbit and vice versa, we've got two different orbital paths on there for our satellites to take. If we've got an object in a high orbit that moves down to a low orbit, it's going to be reducing its GPE. And so it's going to have a higher kinetic energy, which, because the mass of the object isn't going to change, means it's going to be orbiting much faster. So things in lower orbits tend to orbit faster than things in higher orbits. If we move from a lower orbit to a higher orbit, we're going to increase the GPE and therefore reduce the kinetic energy. Okay, two key types of orbit that you need to know are geosynchronous or geostationary and low polar. Geosynchronous is above the equator and it has an orbital period of 24 hours because it stays above the same point on the Earth's surface at all times. It's used for communication satellites. It's also used for things like GPE, anything where you have to be sure your satellite is always in the same place. Low polar orbits are closer to the Earth, like they're low. So we've talked about the need for that to be closer to the Earth. That's a faster orbit. They don't stay above a fixed point. And they're used for things like weather, mapping, espionage. I like the word espionage, it's better than surveillance. Okay, when I say that it's above the poles, it's basically orbiting around between the North Pole and the South Pole.